Good morning, Fantasticos. It's Mr. Calnan here. It is time to start our math lesson for today, lesson 2 in module 5. And what we're working on is using the area models and the distributive property to multiply. Okay, this is a action-packed lesson with some big-time, heavy concepts in it. So we're going to take our time, and I really want you to pause this video if you need to think about anything that I'm saying, rewind it, and if you have questions still, please reach out to me after the lesson, after you watch the lesson on YouTube. Okay? So our I can statement for today says, I can break apart a 2-digit factor to multiply a 2-digit factor by a 1-digit factor. Alright? So we're going to be taking the bigger numbers like we had yesterday. We used base 10 blocks yesterday. Today we're going to be kind of just using a more numerical concept where we're breaking the numbers apart and using what we've learned about multiplication so far. Okay? Let's just go right into it. Spark your learning. A school scramble band gets into formation for a parade. There are 9 rows of 18 band members. How can you make a visual model to show the number of band members that are in the scramble band? Okay? So here is what that band might look like at a big football game or at a parade or something like that. So what we want to do is we want to identify that there are 9 rows of 18 band members each. Okay? And we need to make a visual model to show the number of band members that are in the scramble band. Okay, so the first thing I want us to think about is the fact that there are 9 rows. Okay? 9 rows. Well, rows go across, so we're going to start out by representing the 18 band members in one row. So that would be like a base 10 block that equals 10. Alright, so I have my base 10 rod there, so that's worth 10. And then to represent 18, I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. Okay, so to make my model of 9 rows of 18, I need to copy that over a total of 9 times. So another one here, 1, 2, 3, 4, 5, 6, 7, 8, and so on until I've got 9 rows. Okay, now if I wanted to think about how much I have there now, so it says there are how many band members in the scramble band. One thing I could do is I could count up all these dots that I've got here, right? And then each one of those would be worth 1, and then I could count up all these rods that I have here, and each one of those would be worth 10. Okay? That's a lot of counting if you were to do it that way. You absolutely could do it that way, but think about how many are in each row here. How many dots are in each row for my people who are here in the room right now, Matthew? How many? There's 8, right? And in how many of those rows do I have? I have 8. How many times did I write 8? I wrote it 9 times, right? So also I have 9 of these base 10 rods, which are worth 10, right? So 10 times 9. So what we're going to work on today is breaking a number like 18 apart and doing 2 simpler multiplication problems that I know how to do. Okay? So if you're good with your 9s, you know that 8 times 9 is 72. Okay? And then 10 times 9 is 90. So now I have 2 what I call partial products. They're part of my answer. But when I add them together, I'm going to get the whole answer. So 18 times 9 is 162. Okay, so we're taking a complex multiplication problem and making it more simple by making it 2 problems that I know how to do. All right? Moving on. It says, Willow is working through some math homework. She comes to 7 times 13 equals something. How can she use an area model to help her find the product? Okay, so if we were going to use an area model, then we would want to draw a rectangle down here in this blue area. Okay, so our problem is 7 times 13. Now, I think you guys did some area in 3rd grade last year. Is that true? You learned about area? So area, you know, is the amount of space that's inside of a shape. So I would take, I'm going to draw a rectangle inside here that is 7 units down and 13 units across. So I'm going to start here with my side, 1, 2, 3, 4, 5, 6, 7. And I'm going to go over 13 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Boy, I just made it. Then I'm going to complete my rectangle and label it. Okay? I know that this side of my rectangle is 7. And what we're trying to do is we're trying to break apart our bigger number, like 13, into 2 smaller numbers that are easy for me to solve. Okay? So you can draw your line anywhere, but we know that the whole length across here is 13. So I'm going to just split this into 2 sections like this. Okay? And my sections here are worth 1, 2, 3, 4, 5. This side's worth 5. And over here it's 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now I know that 8 plus 5 is 13. So what I've got here is 2 multiplication problems because I have 2 sort of rectangles here. I've got a 7 by 8 rectangle right here. And over here, this is also a 5 by 7 rectangle. So I'm going to multiply 7 times 8, and I'm also going to multiply 7 times 5 because I broke 13 apart. All right, now 7 times 8, 56. Good. 7 times 5, 35. So now I'm going to take these 2 partial products that I have. They're part of my answer, 56 plus 35, and that will tell me my total product for a 7 times 13. Okay? Take a moment and solve those numbers, add those numbers together, and you will find that it equals 91. Therefore, 7 times 13 is 91. Okay? Now, I broke this rectangle here into 8 and 5. You could have really made this a much easier problem by breaking it into like 10 and 3. That would have been really easy. Or 2 and 11. That would have been a much easier problem for you to do also. You can break it up any way you want to. The idea is use numbers that are easy for you. Okay? There's no set way that you have to do that. All right? I know you guys love it when I do this. Shh, shh. You don't have to answer questions B and C. Okay? We're going to flip right over to page 107 now. It says the next problem on Willow's homework sheet is 3 times 19 equals something. How can you use base 10 blocks to show 3 times 19? Okay. Well, they're not asking us for the answer here. They're just asking, what would you do if we were going to try to solve for 3 times 19? So this goes back to the first problem that we did. We're going to draw a quick picture that breaks 19 into tens and ones. So 3 times 19 would be There's a 10, and then I need 1, 2, 3, 4, 5, 6, 7, 8, 9. A 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. Another 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right? And to show how I would group them, to add them up, I would put a circle around all my 1s and know that that's going to be one of my partial products, and put a circle around my 10s and make that my other partial product. Okay? When you see the words distributive property, that's what this is. Okay? We're breaking the numbers apart. And wasn't distribute one of our vocab words? Yep. Yeah, it was, right? It was like to pass out. So that's kind of what this is too. We're just kind of handing out the numbers that in our problem to multiply two different problems. Or two more simple problems, I should say. Okay? All right. So what that would be is I would have 3 10s, so 3 times 1, 10. And I have 3 groups of 9, 3 times 9. So really that's telling me that I have 3 times 10, because these are all worth 10 up here. And I have 3 times 9, because 9 ones are 9. And my two partial products would be my answers, 30 and 20, not 9, 27, right? 30 plus 27. And my answer is, for 3 times 19, is what I get when I add these two numbers together. 57. Very good. Okay? All right. Down in the check understanding section now, it's asking us to find the product. So they've already broken this number apart for us. So I'm going to circle these 1s, and I'm going to circle these 10s. I'm going to think about how much each one is worth. Okay? The 4 10s is easy for me. 1, 2, 3, 4. That's like doing 10, 20, 30, 40. 40 plus. Now over here, I could count all these squares, but also if you notice, this is an array. It's a 4 by 4 array. So if I have 4 times 4, I have how much? 20. No. 8. No. 16. 4 times 4 is 16. Okay? So from there, then we can find the product by adding 40 plus 16. Okay? 56. All right? And number 2 just does the opposite. It says draw an area model to represent the product. So 3 times 11. So I would want to draw 11 3 times. Okay? And then group them like this. So this one's worth 30, and this one's worth 3. So 3 times 11 is 33. Okay? If you're expert on reflex math, you already know that. Okay? So now I'm going to ask you to pause your video, and I want you to try this on your own. Okay? How can you use an area model to show the product? So in this grid paper here, you're going to draw a rectangle that is 8 by 18, and then you're going to split your rectangle into 2 sections that will make it easier for you to multiply. Okay? Once you've found the area of each separate rectangle, then you'll add those together to get your product. Okay? Similarly, we'll do the same thing on number 4. Use the grid to represent your area model. Number 5, you're going to find the product by grouping your 1s and your 10s and adding them together. Okay? And you don't have to do number 6. Okay? So go ahead and pause the video right now and take a few minutes and solve numbers 3, 4, and 5. Okay, so just to wrap up on the on your own section, we took 18 and I broke it into two parts of my rectangle. So I broke it into 10 and 8. Now when I multiplied 8 times 10, that gave me 80, and the area for the 8 times 8 is 64. So when I add those together, I get 144. In number 4, I broke apart 14, so I made 5 times 10, 50, 5 times 4, 20, so 5 times 14 is 70. And for 7 times 16, we broke 16 apart, so it was the tens and the ones. So there are 7 tens here for 70, and there are 7 rows of 6 here, which is 42, for a total of 112. Okay? All right, hopefully that on your own was successful for you. You are going to now try on your own the more practice and homework, lesson 5.2, which is on page P41 and 42 in your math books. Okay? And if you're watching this, you know that the lesson has already been uploaded to YouTube. So good job, and I will see you guys soon.